Hello and welcome back to another episode of my Blind 70s 5 series. Today we're going to be talking about question number 11, also known as container with most water. This is a medium level question, and for this question we are going to be utilizing the two-pointer technique. So at first glance, this problem can seem a little bit difficult, but we are going to be utilizing two different techniques, one being the two-pointer, and then we're going to use a bit of a dynamic programming type approach to solve this problem. So the problem goes as such. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line, which are I to 0 and I to height I. So if this sounds kind of confusing, just ignore this. We're going to go over it in a second. Find two lines that together with the x-axis form a container, such that the container contains the most water. And then we're going to return the maximum amount of water a container can store. And if you remember from grade school, this maximum amount of water a container can store is just the area. So we're going to be solving for the area of this container, and we're going to be looking for the max area. So in our array, we get the heights. So we know what the heights is between the two. In this situation, our first one is a 1, which is a really little height. So we'd only get a 1 here. So we have to take that minimum height to be able to get that area. And that's how we're going to go down the line. So you're going to look for hopefully the most amount of height and the most amount of width between the 2 points to get your maximum area between these 2 points. So let's go ahead and break down the problem. Okay, so let's go ahead and take a closer look at this problem. So right here, we have our beautiful graph that I drew. And if we look at the values of the graph, we have our height values, which are going to be right here. And this here, this bottom row, is going to be our width. And our width is going to be between 0 and 8, because that is the length of our array. Because as you know, iterables always start at a 0 index, not a 1 index, so we're going to be starting at 0. In our solution, we're going to have a couple different variables that we're going to be working with. One is what we're going to return at the end, which is going to be our max area. And this is where I was saying that dynamic programming kind of approach comes into play, because we're going to be saving this value and return it at the end. And this is what we're going to do instead of saving our values in something like an array. And what this is going to end up doing is saving ourselves some space. So instead of having O of n space, like if you saved it in an array and then we just took the max of that at the end, we're going to instead have an O of 1 space complexity, which is going to give us some efficiency at the end. So like you know with many medium level problems, you are going to be adding in two different techniques together. In this situation, we have the two-pointer and the dynamic programming together to create the solution that we're going to see now. So as I mentioned, we have our max area as our value that we're going to return at the end, and we also have our two pointers, which are going to be called start and end. And I'm just going to call them S and E for now, just to abbreviate. And in terms of our values that we have for them, we have 1 and 7 are currently what we have. Next, we're going to be keeping track of our minimum height value. Our minimum height, I'm just going to call it minimum height, is going to be the height value that we currently have between our pointers. So if it's the start value or the end value, which of these heights is going to be the smaller value? And the reason for that is, as I've mentioned, this is an area problem. So area, the formula is going to be length times width. And in this situation, our length is going to be height. Same thing, height times width, length times width, whatever you want to call it. It's the same exact thing, same concept. And lastly, we're going to have our current area. And for current area, we are going to be keeping track of this to compare with our max area at the end to determine which one is the largest area container. So which container is going to give us the most. And how we're going to start this off is first, we're going to find out which one is our minimum height. And this one's going to stay up here by itself. It's special because we're going to return this at the end. So let's just add a little line between the two. And also, before we do our loop, let's go ahead and add the values for our current area to solve. So how we're going to be solving our current area is we're going to be taking that minimum height, which we're also just going to call MH. So MH times our end minus our start value. So we're going to have our little parentheses here, PEMDAS, and we're going to have that end value minus our start value. And look, it's Halloween. Okay, so now that we have Halloween situated, we have our minimum height times our end minus our start. And this is going to be our area. So our end minus start is going to equal our width. So it's the space between the two. Now that we have that situated, let's start looping through the problem. Okay, so first we have our start is at 1 and our end is at 7 right up here. And if we compare these two values between end and start, which one is going to be our minimum height? Well, as we know, it's going to be this 1 down here because our other one is 7. So our minimum height is 1. And to kind of give you an idea, if we had a bucket and one side of the bucket was a 1 and the other side is a 3, well, our bucket is only really going to be able to hold up to here, because even though we have a 3 up here, it doesn't matter because our 1 is going to determine that. If we can't go up to 3 because it's just going to seep out. So because of that, we're going to have to go by that minimum height for our area problem, or else it's not going to work. Okay, so we have 1. Now let's put it into our current area formula. So 1 times our end, which is going to be at our index, and the end and start in this situation are going to be at the index, not the value. And our index values are going to be 8 and 0. So we're going to take 8 minus 0, and we're going to get 8 is our current max area. 8 is our current area. Now, if we compare it with our max area, which is currently 0. Now, what's the max between 8 and 0? Well, it's going to be that 8. So at the moment, we're going to save 8 here. So for the last part of the solution, now that we know what our max area is and we've saved it for later, put it in our back pocket, we now need to increment or decrement our start and end pointers in order for us to complete the loop. If we don't do that, our values will never move forward and we'll only do one time through. So because of that, we're going to move our values forward based on which one is smaller. And we're going to increment start if start is smaller, or decrement end if end is smaller. And the reason for that is if we've already dealt with a small height, we don't want small height. We want big height because big height is going to give us big area, hopefully, just like basketball. Okay, so start is at 1, which is little, and that's not good. So we're going to move that start value up by 1. We can get rid of this one because it does not matter. We're going to move it forward to 8. Now we have 8 and 7, which are great numbers. So if we take minimum height between 8 and 7, what do we get? Well, we're going to get that 7 over here. Now we're going to do the same thing. We're going to take that 7 times 8 and 1, which is going to equal 7. And then we're going to do 7 times 7, which is 49. 49 compared with 8 is going to be 49 is our max area. And that's actually going to end up being our answer. And so if we go through the rest of the problem, so in this situation, our end value is smaller. We're going to decrement our end. We're going to continue to kind of go down the route. So we're going to get for our next one, we're going to move this over 2, so we can move these over here. And we're going to be at that 3 now. We have 3 versus 8. 3 is the smaller one. And now we have 3 times 7 minus 1, which is 6 times 3 is 18. And we can kind of keep doing the same thing as we go along. But if you take my word for it, that's the answer to the problem. So we can do the same thing here. And I actually do want to handle this situation because this is an important part right here, is we're going to get that 8 here. And we have the difference between 8 and 8. Now, in this situation, there's no real minimum. They're both 8, so that's still going to be saved here. The minimum method handles it the same way. So our minimum is going to be 8. Even though both are 8, we can multiply them together, which is going to be 8 times 5, which is going to equal 40, which is really close, but no cigar and is no good. And this is the important part that I wanted to mention. Now that we have two values that are at 8, which one do we increment or decrement? Well, it doesn't really matter. And this is how I want you to approach the problem in an interview setting, is it really doesn't matter which one moves forward. Either one of these can move forward. It's just dependent on your preference. But what we're going to do is we're going to decrement our end in any situation in which both are equal. In this situation, we move the end forward by 1, and we get end is here. Now we get the same thing. Difference between 4 and 8. We're going to get 4 is our minimum. Now we're going to get 4 times 4 because we keep moving the width down. And that's going to be 16. And you get the point if we keep going down. So 5 times 3 equals 15. If we go forward again, which is that one. Now we got 2 times 2 equals 4. And the same thing, you compare it, 4 versus 49, no, too small, okay. And we move that forward here, and then that one's over. And then now we're at our last value, which is going to be our 6 versus our 8. 6 is smaller, 6 times 1 equals 6, too small, 6 is not big enough, so 49 up here is our max area, and that completes our problem. Let's go ahead and code this up. So we're gonna go ahead and code this up now, and this is a really simple way to, all right, so we're gonna go ahead and code this problem up, and it's actually pretty short, but what we're gonna be doing first is we're gonna take that max area, and I'm gonna do these all on one line. Max area, start and end. So we have our return value, which as you know is our max area that we're gonna be calculating, our start value and our end value, which are our 2 pointers. And max area is going to be 0. Our start value is going to be 0 because it's going to be at the first index in our array. And then our end value is going to be length of height minus 1. And in order for this piece to work right here, we're going to need to take this down a notch and make that just h. And length of height, which is going to be our array, minus 1 is going to take us to the end of our array. So we have our 2 pointers now and our return value. Next, we're going to go ahead and create our while loop. So while start is less than end, and in most cases with a 2 pointer, and pretty much all cases, you're going to be using a while loop. There's very few cases in which you wouldn't use a while loop because you have to increment and decrement as you go along. So just keep it in mind that if you're using a 2 pointer, you're probably going to use a while loop. I don't know a situation you wouldn't, but if there is, prove me wrong. Okay, so we're gonna go ahead and take our minimum height, which is the value we talked about before. And our minimum height, as we mentioned, is going to be the minimum of our height value, start. So when you do this, it's gonna be our start. So this is actually going to be 1, not 0, which is the beginning index. This is gonna be the current value, which is 1, versus our end. And this is how we're gonna write it. Very easy. The minimum of our start and end values, not index. Find the minimum height between the two. Next, we're gonna find our current area. So our current area is going to be that minimum height times our end minus start indexes, not value. And the reason for that is, as we mentioned before, it's the width. This is the width value. So we're gonna have length times width. And to get the width, we have to figure out how much space is in between the 2 points on the container. Now that we have that, we're gonna do our max area again, and we're gonna figure out our max area, our current max area, which for us right now at the beginning of the problem is 0, in our current area. Next, after we have that, we need to have a way that we're going to increment and decrement, as I mentioned before, to increment and decrement our pointers. So we have if h start is less than, and as I mentioned before, you can do less than or equal, or you can do less than, or you can do whatever. You can do this however you want. Less than our end value, not the index value, end value, we're going to increment start. So in the situation that our start value is smaller than our end value, we're going to increment start. And in any other situation for our else value, we are going to decrement our end value, because this is the situation in which the two values of start and end are equal to each other, or in the situation that end is less than start, in which we would need to decrement that end value. Now, all we're going to do at the very end is we're going to return our max area, and that should be it. First, let's just go ahead and check it, make sure it runs good. All right, our output is 49, just like we got. So here's our value. We get 81.98% faster and 69.64% less space. So that wraps up this video. I really hope you enjoyed it. If you did, please drop a like down there and make sure to subscribe to my channel. I'm going to be continuing this Blind 75 series, and I'm going to be doing some other types of videos in the future. So if you liked it, please subscribe. Really helps me out. Otherwise, this is the end. I hope you have a good rest of your day and happy coding.